Alright, what up? This is DIY DSP with a new project, a new secret project. Why is it secret? Well, I can't talk about that because it's secret. But listen up, when you've been in the game as long as I have, you got reasons for things. So stop worrying about things you don't know about, and let's check out what's in these packages. First of all, this is from Amazon. This has got 2 packages in there. There's 1, there's 2, and this is another type of thing. First thing we have is some thermal paste. Now, without saying what this is, can you guess why I might be using thermal paste? One hint is that I'm using 10 grams of it here. Most of the time you need a smaller amount, like 5, even 8 grams, but here I am with 10. So think about that for a minute. Next, let's take a look at the Yanis sensor probe. Now you're going to notice this is I2C. Why do I use I2C? Because I don't have a million freaking hours to mess around with thermistors and tuning them and configuring an ADC and all that good stuff. What we're just going to do is we're going to take this sensor probe and we're going to measure the temperature with these pins here. Notice the utter lack of documentation. I think this is it. You get a tag that literally says SDA and SCK and VCC and ground. So hopefully we'll find some specs for that online. But now here's another clue of what my new secret project is. And I'm going to give this a code name too. I'm going to call this XSF. Alright, only those in the know are going to know what that's about. So we got ourselves 2 of these sensors. Why would I ever need 2 temperature sensors? Wouldn't you think one would cover it? If you thought that, you were definitely wrong. Now let's keep going. Just to show you how much you don't know, look at this. This desk has a trap door in it. So think about that as you're thinking to yourself, yeah, I think I know everything. You don't know everything. And you certainly don't know a thing about my secret project. Now this is from Peltier. Do you know what Peltier makes? Let me just say that you thought you knew. But again, you can't know everything. So what do we have here? This is a high power motor driver. This is 18V18 Shield for Arduino. Now, thing about this is it switches a lot of power. I don't have the specs with me, but I'm not going to say too much about it. Let me just ground myself to this outlet before I open this static proof packaging. All right, and I love Peltier because they always send you a ton of headers with everything as well. Whoa! And there I'll go, all those nice headers. Let's take another close look up here. So this is pretty intense. I think this thing switches something like 50 watts per channel or something like that. But these are the power amplifiers. How is that even possible? I mean, these days, these things are so small and so efficient. It's unbelievable. It's amazing. Anyway, I wanted to take a look at the interface here. It looks like it's got a PWM interface. Like I said, I don't have a lot of time for this project, so but I am going to have to just bust out a basic PWM implementation. Not so bad with microcontroller libraries these days. Now let's go back to the secrecy. Like I said, not everything is what it seems, right? Watch this. Huh! I told you that desk was a trapdoor, and you didn't even think that there would be 2 trapdoors. So let's open up this now. A secret project. You don't even know what it is. You probably don't even, I'll bet you don't even remember half of the stuff that you just saw. Like, think back. What was in this Peltier box? Are you even present? Are you even thinking? What is inside there? Hint, it's a motor driver. And I'll give you another hint. You can drive more than just a motor driver with a motor driver. So think about that. And now think about this. We got 2 temperature probes, and we saw this is a 2-channel motor driver. So we're starting to get a picture. If not, this may really open it up for you. What are these lovely things here? I'm sure some of you have worked with this before. Yeah, that's right. This is a Peltier cooler. This is a relatively modern invention. The first time I saw them was around 20 years ago. And what this is a crazy way to create heat and to create cold. Like normally, if you want to create heat, that's really easy. Just get a power resistor, start driving power into it, bam, you got all the heat you want. In fact, we already have too much heat. We need less heat in electronics. But what this does is it also creates cold. Cold is the hard thing to create. There's no other simple way to do it. You can get a compressor and drive it with a pump and have this great mechanical system and all this fluid going around. But this is like the simplest way. This is called a thermoelectric junction, or a Peltier cooler. Now, there's probably a lot of YouTube channels out there that talk about exactly how it works. So go ahead and look that up. But the quick answer is you apply electricity to here, and depending on how much power you let go into here, it's going to cool on one side and it's going to get hot on the other side. All right? And if you swap the power, that's pretty awesome in itself. But if you swap the direction of the power using something like, yeah, you got it, a motor driver, you could switch the direction and you can make the hot side cool and the cool side hot, like a DLT, okay? You got that? Now, look at all the parts that we got here. We got the motor driver. We got the Peltier coolers. And we've got the temperature measurement. And we've got the thermal paste. Now you're starting to see what we might be making here. But the thing is, even if you know that, you still don't know what it's going to be for. And that's why this project remains a secret. And I'll tell you one other thing. If you don't like and subscribe, then you are never going to find out what this is.